Let's look at uniform circular motion. It's a very interesting concept, uniform circular motion. Now, question to us: what is uniform circular motion? When an object, as you can see right on the screen, is moving around a circular path, that object is moving with a constant or with a uniform speed. All right? So an object that moves with a uniform speed around a circular path, that object experiences what we call acceleration. All right? That acceleration is called a centripetal acceleration because it is directed towards the center. So we are saying that centripetal acceleration is an acceleration that is directed towards the center of a circular path. So in writing, I can write as object moving around a circular path undergoes a uniform speed. All right? Okay? Which means they experience acceleration. All right? So they experience what we call an acceleration. All right? Now, because the object is moving in a circle, the object is moving at a constant rate. All right? So it experiences what we call a uniform acceleration. And I'm saying that is called the centripetal acceleration, which is directed towards the center of a circular path. All right, so that is for centripetal acceleration. And please note that the formula we use for this is A subscript C equal to V square, which is the velocity, over R. So here is a formula we use to solve for centripetal acceleration. All right. So when we say centripetal, it means that the object is directed towards the center. So we're centri, it means center. All right. So the acceleration is always directed towards the center of the circular path. Okay. So let's look at centripetal force. Now, we are saying that as object moves around a circular path, it moves with what? A constant speed. Now, I want us to note that before an object can move, there must be an applied force. Now, the force that causes that object to move is called the centripetal force. I repeat that. The force that causes the object to move around the circular path is referred to as centripetal force. So it is the force that causes the object to move around the circular path. So in other words, we are saying that centripetal force causes centripetal acceleration. All right. So centripetal force causes what? Centripetal acceleration. And please note again, it's called centripetal. That means that it is also directed towards the center of the circular part. So this is the concept of centripetal force and centripetal acceleration. Now we can derive a formula for this by using Newton's second law. With Newton's second law, we can derive an equation for centripetal force. And if you remember, Newton's second law states that a force is equal to ma. Now, I can relate this equation to uniform motion. I can call this my the force. Then I call this the what? The centripetal acceleration, AC. Now, if you remember, I was saying earlier on that A subscript C is equal to what? V squared over R. V squared over R. So I can substitute this value for AC. So therefore, I can say that the centripetal force, which is Fc, is equal to the mass times what? The centripetal acceleration, which is what? V squared over R. So here is a next equation that we can use to solve for centripetal acceleration. We can also derive a next formula from this. If you remember in our class on dynamics, we said that the speed v is equal to the radius times the angular speed. Now we can connect this formula to centripetal force because, as you all know, the object is moving in a circular path. So therefore, I can replace my v or my speed with rw. So therefore, I can say that my force, which is F subscript c, is equal to the mass. The speed becomes rw, so it's rw or squared over the radius. All right, so we can break this further. We can expand. It becomes the mass r squared omega squared over r. All right, what next? So therefore, I can say that my centripetal force is equal to r, cancel one r, so we are left with m, which is the mass, times r times omega squared. So here is a next formula we can use to solve for centripetal force. Okay, so we can also relate centripetal force to frictional force. In our previous class, we looked at frictional forces, and we said that friction is the force that opposes or resists motion. Now, let's consider a car moving in or moving around a curve. Let's look at this. Okay, let's consider a car moving around a curve. All right. Now, if a car is moving around a curve, that car is moving with what? Uniform speed. That is correct. Also, that car we experience what we call static frictional force, which comes from the car tires. All right. So because the car tires is rubbing on the surface, it will produce a static frictional force. All right. So a car moving around a curve, we experience a static frictional force. All right. So with this, we can also derive an equation that we can also use when solving uniform circle. So I can say that frictional force F is equal to what? my friction coefficients of static friction times my N. Here's my frictional force. All right. So the N is our normal force, and our constant here is our coefficient of friction. So I'm saying that the N is our normal force. All right. The N is our normal force. Why? This constant is called the coefficient of static friction. It's called the coefficient of static friction. All right. Now, if you recall in our previous classes, we can break this equation further. And please note that we can also use this equation when solving questions that relate to uniform motion. So I can break this further. My N is the weight, all right? The N here is also known as the weight of the object, okay? So therefore, I can say that my force or my static frictional force can be equal to F subscript S is equal to this friction coefficients times the weight. And you know that the weight is equal to mg. So is N becomes what? Mg. So here is another equation that we can use to solve for centripetal force. Now, please remember that your G is acceleration due to gravity, and G is equal to 9.81 meters per second squared. All right, so we can use this static frictional force F of S, or sorry, F subscript S, to solve questions that relate to an object moving in a circular path. I'll show us two questions of how we can apply these concepts in solving questions. Okay, let's look at a question right here. It says a 6-kilogram ball on a string is rotated about a circle of radius 5.5 meters. So I'm given the mass. The mass is 6 kilogram. I'm given the radius of the circle, which is radius is 5.5 meters. The maximum tension allowed in the string is 40 kilonewton. Please note that tension is the same as force. So by force is 40 kilonewton. We can convert the force to Newton. So that gives us 40 times 1,000. Which gives us 40,000. Newtons. All right. We are asked to find the speed or the maximum speed of the ball. The maximum speed of the ball. Now, to solve this question, I have to use the formula, which says that the centripetal force, F subscript C, is equal to the mass, V squared, over R. Remember, we are asked to find the maximum speed. So what we do next is that we log in the values. My force is 40,000. So I have 40,000 is equal to, the mass is 6 times V squared over my radius is 5.5. Okay, so what next? I have to cross multiply. We cross multiply. So we have 6 v squared equal to 40,000 times 5.5. That gives us 220,000. 220,000. If you are wondering how I got this, I multiply 40,000 times 5.5. That gives us 220,000. What next? We divide both sides by 6. So I divide by 6. Divide by 6. So 6 cancel 6. So I'm left with v squared equal to 220,000 divided by 6 gives us 3666.7. So what next? To get my speed, or the maximum speed of the ball, I have to take the square root of both sides. So the square root of v squared and the square root of this side. Now, from your math classes, from indexes, you know that square root of v squared is v, and the square root of 36666.7 gives us 191.5, approximately to 1 decimal place, 0.5 meters per second. So this is the maximum speed that the ball we require to move around the circular path. Okay, here is our next question. In this case, you can see that friction is acting between the tire and the road, and we are given that friction coefficient as 0.4. So that is my static friction coefficient is 0.4. We are given acceleration due to gravity, which is g, is given as 9.81 meters per second squared. We are asked to find the maximum speed so the car can turn without skidding out of a curve. So the speed is not known. If the radius of the path is 50 meters, so my radius is given as 50 meters. So what you see, or what you can analyze from this question, is that we have two forces acting on this object, or on the car. The first force is the what? Is the force of what? Static friction, which is equal to the friction coefficient times what? Mg. That's the first force acting on the system. Also, we have the centripetal force, because the car is moving around a curve. That means that the force that causes the car to move around the curve is the centripetal force, and that force is always directed towards the center. So we can say that, therefore, my Fc is equal to mv squared over r. So guys, you can see that we have two forces acting on this car. So because I have two forces acting on the car, I will equate them to each other. So I will equate this to this. So therefore I can say that friction coefficient times mg is equal to mv squared over r. Remember, we are asked to find the speed. So to find the speed, step 2, I have to cross multiply. So I will cross multiply. We now have the coefficients, the mass g times r equal to the mass v squared. All right. So now you can see that we have mass on both sides. So because I have mass on both sides, I will have to cancel them. So this mass, they will cancel out each other. All right. So I'm left with what? V squared equal to the friction coefficient times G times R. So what next? I will log in my data. So therefore I have V squared equal to, my friction coefficient is 0.4, so I have 0.4 times my G is 9.81 times my radius is 50. So therefore my V squared is equal to 196.2. So to get my speed, I have to take the square root of both sides, square root of both sides. The square root of V squared is V, and the square root of 196.2 is approximately 14 meters per second. So here again is the maximum speed that the car will require to be able to turn without skidding out of the curved path. So here is our final answer. So here is a practice question for us. We are expected to work out these questions on your notebooks and take a picture of your working, and you can send to this email address.